strategy in an organization needs tools that people understand and can use if they are going to be successful. These tools may require training in various techniques, study of materials, and experience using them. So, what are the most important and common techniques used to support the just-in-time system? The reality is that there are many different techniques, and with that being said, we all know that we need a place to start. So, what techniques would be good to begin with on our just-in-time journey? Over the next few videos, we will introduce 5 different techniques that will get you started. Those techniques are the 5S system, visual management, quick changeover, zero quality control, and total productive maintenance. Now, before we go, here's a question for you to answer in the comments section. What tools, techniques, or methodologies do you think are important to the just-in-time system? We look forward to the discussions that may happen as a result of answering this question, and we'll see you in the next video. In the just-in-time system, we want the right product in the right amount and at the right time. This cannot occur in a workplace that is not organized. Both information and shops that have no organization will eventually become disorganized, cluttered, dangerous, and dirty. All of these conditions create waste. Workers need to wait to find items, move to locate tools, correct defects that may occur, and manage massive amounts of inventory. Poor work conditions, whether service-based or manufacturing, can cause an organization to fail their just-in-time journey. With this in mind, the 5S system is a good system to begin any improvement journey with. Let's look a little closer at this 5S system. Every organization needs a place to start from. Places of work need to have the appropriate conditions as well as maximize performance. This is critical in any improvement journey. Organizations all over the world use the 5S system to improve and standardize conditions in the workplace. There are 5 basic parts of the 5S system: sort, set in order, shine, standardize, and sustain. Let's look at each of the 5 steps of the 5S system. The first step in the 5S system is sorting. In this phase, workers touch everything in an area. They begin sorting the needed items from the unneeded items in an effort to maximize space, reduce inventory, and improve the efficiency of the workplace that it's being performed in. A technique known as red tagging is often used to help teams dispose of some of the items they are getting rid of or are undecided about. Once sorting is complete, teams then begin to place items in appropriate locations according to where they will be used. This is called setting in order. Once items are in locations, many teams choose to place temporary labels, lines, and markings to ensure that items are returned to the proper place. The motto of this phase of 5S is, "A place for everything, and everything in its place." The third S is more about creating a sanitary and safe environment than it is about just cleaning. During the shine phase, workers clean and inspect all work equipment from top to bottom. They look for wear or breaks that could be warning signs of breakdowns, defects, and safety hazards. Standardization is all about locking in the new standard and creating a foundation for the new and improved condition. In this phase, tools like standard operating procedures are implemented and visual management methods are set up so that everyone understands and follows the new standards. The last phase of 5S is sustain. Sustaining requires a great deal of yokoten, auditing, communication, and rewards and recognition so that the effects of 5S don't just stick, but spread throughout the entire organization. And that's it. A brief introduction to the 5S system in just in time. Now, before we go, let's challenge our minds with a question. If you were going to change one thing at your work, what would you change to make the work easier and just as effective? You can place your answers in the comments section, upcoming assignments section, or on a piece of paper. And until next time, my friends, keep on improving, and we will keep on giving you solutions that ignite your power. Had to look for something that you needed right away for hours? Most of us have. In the just-in-time system, making abnormalities visible and placing answers where the questions are may be the most crucial thing to pay attention to. One way the just-in-time system does this is by using different visual management techniques. For example, when organizations use Kanban cards when inventory, information, or tasks are produced, this makes the process visual. Oftentimes, companies may also place signs in an area to remind an employee of safety precautions. And, as we've learned before, standard operating procedures are often placed at a point of use to help workers visually see what needs to be done. These forms of visual management help people find answers where they may have questions. And even more importantly, they make abnormalities visible when they occur. One of the most powerful aspects of visual management is that the techniques used take information and present the information in such a way that everyone can understand it, interpret it, and eventually use it. A common form of visual management that is seen in the United States is the red, yellow, and green light. This standard quickly tells drivers they need to stop, slow down, or go. Similarly, many manufacturing plants use a system known as the ONDON system. The ONDON system uses lights to quickly notify operators of an issue if one occurs. They use a similar color system to traffic lights, and many ONDONs now use other sensory alerts like sound to help people find issues sooner. Another type of ONDON that is used is overhead boards. These boards show which machines are running smoothly and which ones may have abnormal conditions that need to be corrected. Other visual techniques that you may see used in manufacturing plants are shadow boards, which help people identify placement of equipment, lines, which help things get organized, labels to properly identify where items are placed, signboards to give appropriate instructions, and many others. The 5S system is also a very powerful visual system that uses many different methods to identify abnormalities, eliminate the different forms of muda, and keep a workplace safe. One last visual management technique that is frequently used is color coding. For example, when you look at the RPMs on your car, you can see that a car that is redlining is in a dangerous place. Likewise, colors can help us properly match items and avoid frustrating errors. And that's it. A very basic introduction to visual management in the just-in-time system. You can summarize visual management by saying visual management is a way to visually communicate and manage various standards, metrics, improvements, safety requirements, and expectations. All forms of visual management should be clearly displayed and understood with no explanation other than visual analysis by everyone. Now, before we go, let's brainstorm and answer this question in the comments section, upcoming assignment section, or on a piece of paper. What ways can you think of to use visual management techniques to reduce waste in your workplace? We look forward to hearing from you, and we'll see you in the next video. In traditional manufacturing environments, companies generally produce in large lots or batch sizes. Each company does this for different reasons, but in general, it's to avoid lengthy changeover times and to spread the costs of manufacturing over a large quantity of items. In addition to these benefits, however, large lot sizes have some disadvantages too. Large lot sizes create large amounts of inventory, which in turn ties up large amounts of cash. In addition to this, if one part in the lot is wrong, it's a given that other parts will likely be wrong too. With that in mind, large lots may have a limited number of benefits, but they also come with a massive increase in waste, cost, and resources. The just-in-time system moves production through the transformation process in a smaller lot size format. In fact, the ideal is true one-piece flow. In order for a company to produce in a one-piece flow manner, they must learn how to be more flexible with changeovers, more efficient with production, and tighter on quality. One technique that companies use to do this is the SMED approach that was first shared in the book A Revolution in Manufacturing, the SMED system. In the book, Dr. Shigeo Shingo shares the 3 stages of the SMED system that can be used to improve changeovers. They are, first, separate internal setup activities from external setup activities. Then, convert internal setup activities to external setup activities. And finally, streamline all aspects of your setup. With this in mind, we will look briefly at these 3 phases in the next few videos. Until then, consider the following question that you can answer in the comments, upcoming assignments section, or on a piece of paper. How long does the average changeover take you in your place of work, and why do you think it takes so long? We look forward to hearing back from each of you, and we'll see you in the next video. The SMED system is based on 3 stages: separate internal setup from external setup, convert internal setup activities to external setup activities, and streamlining all aspects of your setup. In this video, we will introduce the first stage of SMED to you: separating internal setup activities from external setup activities. Internal setup refers to the activities associated with elements of a setup procedure that can only be performed while a process or machine is not running. External setup time is the amount of time associated with the elements or activities of a setup procedure that are performed while the machine is running. In many traditional changeover activities, internal and external activities are mixed together. In other words, changeover activities that could be performed while a machine is running often wait until a machine stops. In other words, Many things that could be done while a machine runs sit and wait until the machine stops. This drastically increases changeover times and other forms of waste. In this first stage of separating internal and external setup activities, external activities are sorted out of the process so that they can either be done beforehand or after when the machine is back up and running again. This first phase usually involves a lot of checklists, function checks, and watching for opportunities to reduce transportation waste, specifically with tooling and parts required. Some critical items to look for that can reduce waste by as much as 50% are bringing all the necessary tools, parts, and materials to the machine while it's running, and looking to confirm the function of parts that may be exchangeable or interchangeable before stopping a machine to begin the changeover process. Now, before we move on to the next video, here's a question that may help you improve your changeovers right away. While watching a changeover, do you see any steps in the changeover that could have been performed while the machine was running, but instead waited until the machine was stopped? Share your answers in the comments section, upcoming assignments section, or on a piece of paper, and we'll see you shortly. In the SMED system, 3 phases of implementation occur: separating internal and external setup activities, converting internal setup activities to external setup activities, and streamlining all aspects of a setup operation. In this video, we will introduce the second stage, converting internal setup activities into external activities. Once you have identified and separated both internal setup activities and external ones, you can then go back and look at the value stream closely again. You may be thinking, what am I looking for? In this phase, you are looking to find internal activities that may be able to be performed externally. Put another way, you are looking for activities that are performed while the machine is stopped and trying to find ways to perform these activities while the machine is still running. Some of the more general activities that are common improvements in Stage 2 of the SMED system are preparing tools, conditions, and materials in advance. For example, get your tools while the machine is still running. Heat up tooling with a heater instead of using trial shots, and have materials ready before the changeover occurs. Find tooling and devices that automatically measure and position without you having to manually measure for appropriate fits. And that's it. Stage 2 of the SMED system. Remember, this is just an introduction to the SMED system. As you gain more experience and confidence, you may consider diving deeper into SMED with books or studying the detailed Reduce methodology, which is based on the SMED system. Now, before we go, let's challenge our minds a little. What activities can you think of that are performed while a machine or computer are stopped that could be performed while the machine is still running? We look forward to hearing from you, and we'll see you in the next video. The single-minute exchange of dyes system created by Dr. Shigeo Shingo and the Reduce methodology that is based on Dr. Shingo's system are powerful ways to reduce changeover times. In this video, we will briefly introduce Stage 3 of the single-minute exchange of dye system. streamlining all aspects of your setup. After completing the first two phases of the SMED system, the third stage looks to really make the value stream flow. This oftentimes involves reviewing the value stream and eliminating various forms of muda and moving from sequential operations to parallel operations, which allows two operations to be completed at the same time rather than waiting for sequential completion of each of the operations. Two other common methods that people find very beneficial in their efforts to further streamline all aspects of the setup process are using functional clamps in place of nuts and bolts. Not only does this reduce many forms of muda, but it can also reduce the need for many different types of tools. Using numerical settings can also help eliminate the need for excessive testing and trial and error adjustments that oftentimes need to be done in traditional manufacturing environments when a changeover occurs. And that's it. A brief introduction to the final stage of the SMED system. Now, before we go, please take a moment to answer the following question in the comments section, upcoming assignments section, or on a piece of paper from your desk. What other ways can you think of to streamline your setup or changeover activities? Thanks again for watching, everyone, and we'll see you in the next video. Have you ever wondered what might happen if I had zero quality control? Well, here's the answer. Things would go rather chaotic. That's right, quality control is critical, and how your quality control is implemented is even more critical. Zero quality control refers to a system that was developed by Dr. Shigeo Shingo and used in many different businesses, including as part of the Toyota production system. It refers to the notion that quality could and should achieve zero defects. Zero quality control is a method or approach for achieving zero defects in an organization. Zero gives reference to the objective of ZQC, which is to produce products and services with absolutely zero defects. And of course, we all know that zero defects is what every customer expects on every order. Scrap, rework, defects, and defective parts can absolutely destroy a company's good standing with customers, as well as suppliers. That is why the just-in-time system uses zero quality control to maintain or progress towards perfect quality. Companies that are striving to be lean or implement just-in-time do not have excess inventory that they can pull from to replace parts that have defects, or worse yet, become defective. As such, quality must always strive to have zero defects. How is this done? The zero quality control system focuses on detecting and preventing abnormalities before they occur in effort to achieve zero defects. In other words, the ZQC system attempts to prevent defects, errors, and mistakes before they occur. It does this by harnessing the power of 4 different elements which make up the ZQC system. The ZQC system seeks to fully implement source inspection. Source inspection is inspection that occurs at the source and is a very powerful method for catching errors before they turn to defects. The ZQC system also uses 100% inspection. This form of inspection inspects every piece of work and not just a sample size. In addition to source inspection and 100% inspection, the ZQC system seeks to have the quickest feedback possible. This is referred to as immediate feedback. The goal of immediate feedback is to shorten the time between the error, mistake, or defect and the time of correction. Finally, ZQC uses the famous Poka-yoke system, otherwise known as mistake proofing. People make mistakes and errors occur from time to time. Poka-yoke is a critical piece of the system in preventing and detecting these abnormalities. Put very simply, Poka-yoke is a series of techniques used to error-proof, mistake-proof, or create a fail-safe process that is designed to prevent errors, defects, or mistakes. Even more specifically, a Poka-yoke is any mechanism in a lean manufacturing process that helps an equipment operator avoid mistakes. Its purpose is to eliminate product defects by preventing, correcting, or drawing attention to errors as they occur. And that's it. A very condensed look at the ZQC system and mistake proofing. Now, before we go, please consider this question and answer in the comments section, upcoming assignments section, or on a piece of paper. How would having 0 defects in an organization improve that organization? And where would you start your 0 defect journey from? We look forward to seeing the discussions and answers. And as always, thanks for watching right here on Lean Strategies International LLC, where solutions ignite your power. One of the most critical elements of zero quality control is Poka-yoke. In this module, we will introduce Poka-yoke to you. Let's get started by answering the question, what is Poka-yoke? Poka-yoke is a Japanese term that means mistake proofing. It is a series of techniques used to error-proof, mistake-proof, or create a fail-safe process that is designed to prevent errors, defects, and mistakes. Even more specifically, a Poka-yoke is any mechanism or tool in a lean manufacturing process that helps an equipment operator avoid mistakes. Its purpose is to eliminate product defects by preventing, correcting, or drawing attention to errors as they occur. Now that you know what a Poka-yoke is, we can introduce how Poka-yokes work. Poka-yoke devices essentially help facilitate 2 very critical aspects in preventing errors. First, they help accomplish 100% inspection. Next, they provide quick and almost immediate feedback when errors do occur that helps an operator take corrective action before the error turns into a defect. In the simplest form, a Poka-yoke will either shut down a process, machine, or line when an error occurs, or signal the operator. The most effective Poka-yokes are achieved with source inspection. However, Poka-yokes can also be effective with informative inspection methods. Keep in mind that informative type Poka-yoke checks only occur after the defect or error has already happened with either the successive check or self-check methods. While this is effective in stopping the defect from traveling, it is not as effective as a Poka-yoke that occurs at the source. The concept of Poka-yoke was formalized and the term adopted by Dr. Shigeo Shingo as part of the Toyota production system. Dr. Shingo outlined the Poka-yoke techniques in the book Zero Quality Control, Source Inspection, and the Poka-yoke System. Keep in mind that much of the Poka-yoke system requires quality-focused behaviors. Those involved are attempting to achieve zero quality control and should support 3 basic principles of defects. Don't accept a defect, don't make a defect, and don't pass on a defect. And that's it. Poka-yoke. Now, Let's end with a challenge. You can answer the question in the comments section, upcoming assignments section, or on a piece of paper at your desk. Is there an error that you see every day? And what ways would you prevent that error from occurring? We look forward to opening this discussion up, and we'll see you soon. No organization can be effective if the equipment it uses is always breaking down. In many cases, if the equipment needed to produce products or information is down, then a business is at a complete standstill. With this in mind, producing to customer demand requires a company to be able to produce. If they cannot, no strategy, including just-in-time, will be successful. So, how do companies combat this challenge? Most organizations utilize a strategy known as total productive maintenance. Total productive maintenance, or TPM as it is often called, is one of the best ways to keep an organization up and running. Total productive maintenance is a maintenance strategy which focuses on achieving improved performance, reduced breakdowns, and better quality through preventative maintenance and effort of employees. TPM really focuses on a few main objectives. The first and most obvious is achieving the most effective use of every piece of equipment possible. Next, TPM tries to avoid any type of loss through the building and monitoring of a detailed loss prevention program. As with any type of continuous improvement strategy, TPM also seeks to bring people together in an effort to improve equipment maintenance and effectiveness. This requires the support, consensus, and cooperation of everyone from the top down in an organization. It also requires an organization to adopt a team-based approach in the effort to achieve absolutely no losses in quality or machine downtime. The strategy is based on 8 pillars. Those 8 pillars are continuous improvement, autonomous maintenance, planned maintenance, quality maintenance, cost deployment, early equipment management, training and education, and safety and health. As you can see, TPM can improve the overall equipment effectiveness through many different approaches that will involve and include everyone in an organization, especially people on the front lines or at the Gemba. And that's it, a very basic introduction to total productive maintenance. We'll see you in the next module, where we will look at one piece of the TPM puzzle. Autonomous maintenance is a pillar in total productive maintenance. In fact, it is the first pillar of total productive maintenance. This pillar advocates giving everything that workers need to assist in keeping machines running. When machine operators have the means to support maintenance with maintenance technicians, it indeed helps increase efficiency and productivity in an organization. So, just what is autonomous maintenance? Autonomous maintenance is an approach that is frequently used to improve maintenance in an organization. It gives machine operators responsibility for basic maintenance tasks rather than relying on dedicated maintenance workers and technicians. One of the benefits is that it gives operators more control and authority over the equipment they use. This in turn allows maintenance personnel to focus on more complex and specialized maintenance work that may require more in-depth expertise. When a company implements autonomous maintenance as part of a total productive maintenance strategy, They also empower people. For example, operators learn how to clean their machine properly on a daily basis. Workers can update their own software and other various tasks that are simple enough. They learn how to look for signs of trouble as they inspect their machines daily, and they also perform daily maintenance tasks, such as lubricating joints, putting air in tires, and running regular maintenance updates where appropriate. This puts workers in a position where they are on the same team as maintenance technicians, and everyone is working together. Now, given that this is only an introduction to autonomous maintenance, we'd like to ask a question so that you can ponder a little more about this new subject of autonomous maintenance. If you performed basic maintenance daily on machines, computers, and other equipment in your place of work, do you think this would help reduce unplanned downtime of machines? We look forward to hearing from you, and we'll see you in the near future.